Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals, right? And here our definite integral, it involves the greatest integer function, right? So here we have to find the value of this definite integral, that is e cube minus 1 to e raised to 4 minus 1, and the integrand is x times greatest integer of log x plus 1, right? So let us start and let us call this integral as I, right? So here we are going to use the method of substitution, right? So let us put t is equal to log of x plus 1, right? So here we are changing the variable x to t, and we are taking t is equal to log of x plus 1. So this implies that e raised to t is equal to x plus 1, right? And x can be written as e raised to t minus 1, right? And dx over dt, that is differentiating both sides with respect to t. So we have dx over dt is equal to e raised to t, and dx is equal to e raised to t dt, right? So now we'll use this dx, or we'll replace this dx by this value, that is e raised to t dt, right? So here what we have done, we are assuming t is equal to log of x plus 1, right? Now let us change the limits accordingly. So here we see that x varies from e cube minus 1 to x is equal to e raised to 4 minus 1, right? So here we can find out the values of t for these two values of x, right? So t is equal to log of x plus 1. So when x is e cube minus 1, we have e cube minus 1 plus 1, and 1 get cancelled. So this is log of e cube, and log e cube is 3 times log e, and log e is 1. So we have 3 times 1 is equal to 3, right? So here we are assuming that the base of the logarithm is the exponential number e, because the log of e can also be written as log of e to the base e, that is 1, right? So here when x is e cube minus 1, t is 3, right? Similarly, when x is e raised to 4 minus 1, t is the log of e raised to 4 minus 1 plus 1, and 1 and minus 1 get cancelled. So we are left with log of e raised to 4, and this is 4 log e, and again log e is 1. So we have 4 times 1, that is 4, right? And here we have used the properties of log, that is log of a raised to b is b log a, right? So now we can write this integral I in terms of t by taking dx is equal to e raised to t dt, and t is equal to log of x plus 1, and the limits are from 3 to 4, because x varies from e cube minus 1 to e raised to 4 minus 1, right? So now this integral I can be written as t is equal to 3 to 4, and for this x we can write e raised to t minus 1, right? And here we have for greatest integer log x plus 1, we can write greatest integer t, and for dx we can write e raised to t dt, right? Okay, so now this is the case, and now we can rewrite this integral as 3 to 4, and we can multiply e raised to t minus 1 with e raised to t. So we have e raised to 2t minus e raised to t, and here we have greatest integer t and dt, right? Now here we have to make use of the definition of greatest integer function, and here we see that the limits of integration are from 3 to 4, right? So when t it varies from 3 to 4, then the value of greatest integer t is equal to 3, right? So the value of greatest integer t is 3 due to the definition of greatest integer function, because t it lies between 3 and 4, right? So we can verify this expression by taking some special values of t. Let us take t is equal to, say, we can take 3.5, right? So 3.5 lies between 3 and 4. Therefore the value of greatest integer 3.5 is equal to 3, right? So now we can rewrite this integral I as 3 to 4, and we have e raised to 2t minus e raised to t, and for this greatest integer t we can write 3, and here we have dt. Now we can take this 3 outside the integral, and we have 3 to 4 e raised to 2t minus e raised to t, and here we have dt, and this is 3. And now we know that the integral of e raised to 2t is e raised to 2t over 2, and the integral of e raised to t is e raised to t, and the limits are from 3 to 4, right? So now we can simply substitute the limits. So we have 3, and let us first take t is equal to 4. So we have e raised to 2 times 4 is 8 over 2 minus, here we have e raised to 4 and minus, and when we take t is equal to 3, we have e raised to 6 over 2 minus e raised to 3, right? Okay, so now we can take e raised to 3 common. So we have 3 times e raised to 3, and we have e raised to 5 over 2, and here we have minus e, and here we have e raised to 3 over 2, and here we have 1, right? And now we can simplify it. This is 3 times e raised to 3, and this is e raised to 5 over 2 minus e cube over 2 plus 1, right? So now this expression can also be written as 3 times e raised to 3, and we can write it 1 minus e cube over 2 plus e raised to 5 over 2, right? So viewers, the value of this definite integral involving the greatest integer function is given by this expression, right? So this is how we solve this problem.